So the lesson for today, the reason I combine these two because they are exactly they're using the same concept. Let's take go back and forth. And also I want to shortening the unit 9. Okay. So let's warm up. Hope you still remember what is log. What is log? Very good. Log is like the inverse of reverse, more like a reverse of exponent. And you go backward. Okay. What is the log base? How do you read it? Log base 2 of 2. Very good. Now what is the log base 2 of 2? 1. Very good. Because 1 to the power 2 to the power 1 is 2. That's how you ask yourself. Remember? 2 to the power 1 is 2. That's how the log works. What is the log base 2 of 8? 3. Because 2 to the power 3 is 8. Yeah? Okay. Very good. What's the log base 2 of 2 times 8? 2 times 8 is 16. 4. 2 to the power 4 is 16. Good. Oh, you guys very good at log then. Log base 9 of 81. Easy. 9. 2. Log base 9 of 9. 1. Easy, right? Yeah? Oh, we're going to test it right now. Okay. What is this? Log base 2 of 2 cubed. What is 2 cubed? 3, right? You also see, you can also see this. Log base 2 of 2. Are they the same? You can also cancel it. So what do you have left? 3. Okay. How about this? You can also cancel it. And you have 3. Now, did you notice anything here? They are the same. These two are the same. You see that? They're the same. They both give you 3. So now what can you what do you think? What do you wonder? What do you wonder? They are the same. Right? So how do you think you can go from here to here or from here to here? Huh? No, this is not Snell method. Snell's method is convert between the log and exponential. These two are the same. What do you notice? What do you notice? Huh? Only the 3 that move, right? Only the 3 move. So do you remember the notes I told you to leave five lines? Yeah, so we're gonna go back there and we're gonna update the property. Okay. You wrote 5 lines? You wrote the 5 lines? So this is the most powerful and a very, very useful property of log. Okay, let's write over here. Okay, let's write over here. So continue. We have 1, 2, 3 already, right? So number 4, they put a star here because this is the most powerful of the log. Very, very popular and very common. Okay, if you see, let me stick with the letter. If you see the power, who read my mind? If you see the power, what can you do with the power? You can move it to the front. Move it to the front. This very, very popular. Okay, very popular. How many lines we have left? 4 lines, right? Okay. So let's do a couple of examples about this property specifically. Example. Okay, direction is expand the expression. Okay, number one. Easy one. What is it equal to? Just 3. What is it equal to? So the power, you're gonna bring the power to the front. So you're gonna have 3. Well, what is the log base 10? Do you need to write 10? 10 is the invisible 10, right? Similar to like square root of 9. Do you need to write 2 here? No, that's invisible 9. Or 9 to the power 1. You don't need to write it because they are invisible. They are invisible. Okay? Same thing here. When you see the log base 10, you don't need to write it because they know automatically this is invisible 10. That's it. Yeah. Huh? 3 log s, yes sir. You just move the 3 to the front. And then the invisible 10, you don't need to write it. Okay? 2 times 8. That's why you got 16. Yeah. 2.8 is not going to give you 16. Right? Makes sense. All right. Good question. Just ask me any question. Yeah. Like, Mister, do you have a twin? No, not that kind of question. Huh? What you going to do? Easy. You just need to move the negative 7. Not the 7, but negative 7. Move the negative to the front. Right? So negative 7 log base 5 of A. That's it. Easy. Huh? Flip? No. No. Negative 7. Now it. No. Okay. That's a good question. This is the power, right? This is the power. Usually you're gonna flip, but no, this is not. It's not about flipping, because this negative here, when you bring to the front, it's become just a number, no more power, so no more flipping. Yeah, so that's good. That's good. You connect your all previous knowledge we learned. Remember this one, you move to the front already, so now this is not the power. You're not gonna flip the number. Yeah, good, very good. Hold on. Okay, let's give away 1 point then. Let's give away 1 point. Can you see it? Okay, let me write over here. What is the name of the E? Exponent, natural log. That's chemistry. Euler number. Euler number. What is it? What is the approximate of the number? 2.72. Yes, 2.72. Okay. Mm-hmm. I'll round it up. No. Keep it. I just round it up. This is the correct one. 7182 and more. Like pi. I round it up to 72. Just short, right? In short. Yeah. Huh? So how do you read this one? M&M. M&M like chocolate. Yes, you need to do that one. Okay. Do you see any power here? No. So you need to make the power happen. How do you make the power happen? Yeah, the story, the king and the god, right? How do you changing it? Right. You want to change the radical form to the exponential form. What is the power? 1/3, right? The power invisible one, and then the cube is the outside, so the bottom 1/3. Square root is 1. Square root is 1/2. Cube root is 1/3. 4 root is 1/4. Okay. Now, power here, what can we do? The most powerful log property is you bring it to the front. Okay, bring it to the front. And what is the other thing we can do? ln. Log base e is ln. How do you say the ln? What is the name? What's the real name? Natural log. Okay, natural log. So ln, 1/3, right? 1/3 first. 1/3 ln x. That's the simplest way you can write. Let's see what that's the 1 point. And Layla 1.2. Yeah, for the king of the god. Huh? Say again, sit louder. Yes, so ln is log base e. That's it. It's just a short way to write it. Yeah, that's it. So in the calculator, you will see the word ln. Because in the calculator, the old calculator, they don't have like you cannot change in the base. They always base 10 because they always have log. They don't have base for you. Later on, we're gonna learn about how to find like base 5, 7, like this. In the calculator, for now, you don't know how to press this because they don't have this. They only have base 10. So later we're gonna learn this is actually equal to base 10 of 7 and base 10 of 5 divided. Later we're gonna learn about this. Okay, this is how you're gonna press on a calculator. Later. All right, first come first serve. Raise your hand. Only one person because we have 2 lessons. I'm not gonna walk around. Just raise your hand first. You get point. Give me the whole answer. 3 seconds. 3, 2, 1. Okay, Allison. No, never mind. Ernesto. 5/8. 5/3. Yes. Log 8 of x. That's it. Right? They get 1 point to Ernesto. So one step that in the middle is you're gonna convert. Same thing. You're gonna convert the radical into exponential, and then you're gonna move the exponential to the front. So 5/3 log 8x. Yeah. Why is that? All right. Property number 5. Are we good with this property? Yeah. Very powerful. Keep that in mind. Okay. Very powerful. Later on, when you see the number in the front, you should also know how to bring it back to the power. We're not gonna call expand, but we call condense. That's the 9f later. Okay, number 5. If you have log, let me stick with the letter. Still base b m time n. Okay. It's going to be log base b. Huh? No, this is a property. This. Yeah, like 2 times 8, right? 2 times 8 is equal to, yes, it's equal to log base b of m plus log base b of n. This is also very popular, but less popular than this, but it's also very common. Okay, so that means when you have 2 numbers multiply, you can break them out like sum. Just similar to like this: a to the power m times a to the power n. What do you want to do with the power? You add them, right? You add them, right? Do you remember? Remember that log is the reverse of exponential. So the same thing here. When you multiply, that means you add the power. So same thing here. When you multiply inside a log, that means you add those 2 logs. You break them out at a sum. Make sense? Okay, let's do a sample. It will make more sense to you. Number 5. What is the log 10 6x? What is this? Log base 10, but then the base 10 invisible 10, you don't need to write 10. Okay, I want you to get used to it. That's why I keep writing 10. So now you don't need to write 10, but that's invisible 10. Log 6 plus log x. That's it. One step, one line answer. Easy? Too fast? Is that okay? Any question? Okay. Number 6, I'll give Alicia 1 point. Nella, let's go. Huh? This is 3 times x to the power 4. There's no parenthesis, okay? So the 4 only applies to the x, the 4 not applied to the 3. Be careful, be careful. It's not like this. It's not like this. Maybe we can do another 7 like this, okay? Number 7 like this. We're going to talk about it later. But they're different, okay? And that's good one. I'm going to add. So, Nela? Right. This is multiplication. Break the multiplication first. What do you have? Log base 4 of. This is multiplication. This is multiplication. What you're going to do when they multiply? You break them out as a sum, right? So log base 4 of 3 plus, very good, of x to the power 4. And now what can you do with the 4? Can you leave it like this? No, you need to put it in the front. Okay, so now it's equal to log plus 4 log. Can we cancel 4 log 4? Yeah? No. Okay. Only 2 types that you can cancel. Log base 4 of 4. Or 4 to the power log 4. Like this. Not multiply. Okay? This one you can cancel. This one can cancel. But this one you cannot cancel it. Good. Let's give another 1 point. Very good. But this one just came on my mind. How about this? Huh? So 4 affect to both of these, right? Are you going to break them? No, you need to bring the power first. Okay, but everything here is to the power 4. So you're going to bring the power 4 to the front first. Log base 4, 3x. And now you can break the multiplication. Okay? So when you break them, be careful. They need to have a parenthesis. You're going to have log base 4 of 3 plus log base 4 of x. You can leave it like this, or you can also distribute a 4. You know what I mean? Yeah, because this 4 right here is applied to both of them. So if you don't have a parenthesis, like this, it's going to be wrong. Because that means the 4 only apply to this, not this. But the 4 actually apply to the whole thing. So you need to have a parenthesis. Okay, be careful. This small thing right here can cost you an automatic lag because it's changing everything. Map, one minor mistake going to changing everything. Okay. Let me write right here so you can see. What about this? Hama. One try. One try. It's very similar. Does 2 here affect to everything inside? Yes, right? So 2xy. Okay, let's do one by one. Let's do slow so everybody can keep up. So first, you just need to bring down the power to the front. Okay. And now what you're gonna do when they have multiplication a lot inside here? You're gonna break them by mm. When you have multiplication, you're gonna break them each of them separately. They have their own log. They have their own log. Ah, okay. So Herma also distribute them as well. So she say 2 log 2 here, and then she also say 2 log 2. That's good too. That means she skip this step. She just distribute everything. That's good. Log base 2 of x and plus 2 log 2y. Yeah? Is that a final answer? Why not? It is? No. No, she only that one just said. Instead of parentheses, Herma already distribute everything. You see everything have the 2? Yeah, she skipped a step. So she did the mental map, like she just distribute everything. That also good, right? Because the 2 apply for everything. You can also do 2, 2, 2 here. Log 2 by 2, right? Is equal to 1. So you only have 2 plus 2 log 2 x plus 2 log 2 y. Good job. Let's give Herma 1 point and equal 1.2. Make sense? How many of you not going to be here on Thursday? Not going to be here. We're not going to be here on Thursday because of AB test, something? Raise your hand, so we're going to count. If more than half, then we're going to skip it. If less than half, then we're going to continue. Raise your hand, raise your hand. Oh, only 6. Oh, still good. It's still good. I'm not recorded. You'll be fine. All right, try by yourself and raise your hand when you're done. Okay, so first you need to change the radical into exponential, right? So log base 2, 2x to the power. How are you changing it? To the power 1, 4. Yeah? 1, 4. 4 root is 1, 4. But you need to have the parenthesis. Why? Because this whole thing here is inside the 4 root. Okay. Now, what you gonna do with the 1, 4? Are you take care of the 1, 4 first, or you take care of the multiplication first? Are you take care of the 1, 4 first or multiplication first? 1, 4 first. Okay. Yeah. So 1, 4. All right. And now this is multiplication. Now little multiplication. You can break them out into two separate things. Okay. So 1, 4 log base 2 of 2 plus 1, 4 log base 2 of x. I also distribute it. Okay. If you don't want to do that yet fast, then you can write it this. They did your parenthesis. Okay. And later on, you're going to distribute it. It's going to be the same anyway. But what is the log base 2 of 2? 1. It's 1. It's still 1. It's not gone. A lot of you didn't see that term on your answer. You still have that one. You still have that one. So if you distribute it, you're going to have 1 over 4 plus 1 over 4 log base 2 of x. Yeah, a lot of you forgot this one. They cancel out. They become one. They're not gone. They didn't gone. It doesn't like disappear. Try by yourself. You're gonna do it. You get point. Okay. Yeah. Rachel, let's go. What you gonna do first? Okay, let's come back. Let's come back. Let's come back. You gonna take care of multiplication first, or you take care of the power first? Yeah, you're gonna. Okay, you're gonna change that first. Okay. So y and then x to the power 1/3, and then that's equal to Rachel log base 7 of Rachel y. No, no. You want to do the x first? It's gonna be same thing anyway. So plus log base 7 x to the power 1/3. Same thing. Order doesn't matter, right? Order doesn't matter, right? 2 plus 3 equal to 3 plus 2, right? Order doesn't matter. Same thing, 2 times 3 and 3 times 2. Okay? So, okay. Now, what are you going to do next? You're going to bring it to the front. That's all you can do. Okay? Let's give Rachel also 1 point. Okay, so the next property is, so we saw the multiplication already. What do you think is the next one? Division. So log base b m divided by n equal to, what do you think? If the multiplication is plus, then the division is minus. So log base b of m minus log base b of n. You kind of guess already, right? Similar to the power. When you see the power, a to the power m divided by a to the power n. What is it equal to? A to the power. Do you remember this? M minus n. Yeah. Remember the log, they just reverse of the power. So they kind of similar to this. Yeah. Uh-huh. Or like this, whatever. Okay, number 11. Easy. Easy, easy. Easy, easy. You should make a t-shirt like name Easy. That's easy, Mr. Lee. And then put all your name on the back. Like t-shirt. They didn't get back. It's okay. Just go. Yeah? Okay, Nella? Yeah, let's go. Log base 2, 7 minus log base 2, 8. You find the answer? All right, Alex? Why no? Did you say no? Or who said no? All right, Gerson? Oh, okay, hold. You see that? Is that a question? 3? Or the statement? 3. 3, right? 2 to the power 3 is 8. So log base 2 of 8 is 3. Này là 1 point. Go on, try it. Really? Let's go. You can do it. You can do it. Get some point. Get some point. First, are you going to take care of the power or the multiplication? No, let's take care of division. Okay. Well, there's a many way. You can do take care of this one first, take care of this one later. Or you can take care of division first, take care of this later. The power save it to the last. Okay, the power save it to the last. Because if you don't have the order, you don't have a system. You're gonna mess up. Okay. So what do you think? What do you want to do first? Multiplication first. You can also do both of them at the same time. I'm gonna show you how to do it. Okay. Now, first, what is a log base e? Ln. Okay, so we're gonna change this one into Ln. Yeah. So let's write this note down. Let's write note down. I think this is gonna help you. Tip. Plus the term on the top and minus the term on the bottom, at the bottom. Okay? So whenever you see the term on the top, you're going to add them. But whenever you see the term on the bottom, you just minus them. This sounds very simple and it makes sense. But when you see a lot of term, it's going to help you. You're going to see it later. So I really continue. So ln 2 x cubed, is it on the top or on the bottom? On the top, so you just need to add them, right? So plus ln x cubed. Now y squared, is it on the bottom or on the top? So you subtract, so minus ln y squared. Yeah, and take care of the power the last. Okay, this is power 3. You're going to bring the, so I really continue, finish it. So ln2 plus the power. What you gonna do with the power? Property number 4. What you gonna do with the power? What you gonna do with the power? You bring it to the front. Okay, so you're going to have 3 ln x. Continue. Minus, yes, that's 2 ln y. Yeah, thank you, Riley. Thank you, Dana, too. Thank you, Riley, 1 point. Good. Make sense, everyone? Yeah. 13. Any question so far? Any question? Okay. Even there's no silly question, to ask me any question. This one. So this is multiplication. Multiplication, that means you plus them, right? Or you can use this one, the tip. When they're on the top, you just plus them. Now y2, that means they divided on the bottom. That means you subtract them. That's it. I just break each of one. I have 3 terms, right? I have 2. I have x cubed. I have y squared. This one on the top plus. This is on the top plus. This on the bottom minus. That's it. I break them out. Okay. All right. 13. Last one for this 9E. Last one. Yeah, we're not start 9F yet. All right, do this one. First 5%. How many terms do you see here? 4, right? One here, one here, one here, one here. Okay. Whenever it on the top, you plus. Whenever it on the bottom, you minus. Okay. You're not gonna back. You're not gonna go back, huh? Irene and Gabriela. Huh? No, I'm not going back. I'm not going back. We need to move on. Okay, how many terms? 4 terms, right? Whenever you see on the top, you're gonna plus. Whenever you see at the bottom, you minus. But before that, you know that x is to the power 1/2, right? Square root is 1/2. Square root is 1/2. So you have log 4 x to the power 1/2 plus log 4 y squared 5 on the bottom. So you're gonna minus log 4 5 minus log 4 z cubed. So what's it good? And then just move the power to the front. Move all the power to the front. Okay, so you're gonna have 1/2 log 4x plus 2 log 4y minus log 4 5 minus 3 log 4 z. That's it. So now we're gonna go to the 9f. The reason I combine them because they are exactly the same. Let's just go backward. So 9e, I give you 9e, I give you this. You give me this. 9f, I give you this. You're gonna give me back this, right? Like 9f is you go this way to this way. That's it. That's why we can combine them. So for example, let's start. We can continue number of the example as well. So 14. Okay. So because they are same day. Okay, log base 5 of x plus log base 5 of e. Condense. You know what a condense mean? You're gonna pack them, right? You're gonna shorten them. Yes. So what is this? When you add them, what does it mean? That's it. Log base 5 xy. That's it. Negative 1 point, very fast. Make sense? All right. You want to try this? Raise your hand, raise your hand. All right, Nico. You need to write log 10? No, right? Invisible 10. Huh? Judge yourself, judge yourself. Don't listen to anyone. All right, who else? I listen. 40 divided by 4, right? This is subtraction. This is subtraction. That's mean when you go backward, they are division, right? So now log of what? 40 divided by 4 is 10. Oh, what is the log 10? Just log. Log 1? Log E? Oh, interesting. We have been going to a very complicated problem and now what is log 10? You don't know? What is log 10? 1. Because log is log base 10. Log base 10 of 10 is 1. What is ln e? What is the answer of e? Is 1. Because ln that means log base e. Okay. Oh, I listen 1 point, right? They need to be same base. You cannot do anything if they not have the same base. Okay. So first, you're gonna bring the power first. Okay. For this way, for the forward production, for the span, you're gonna take care of the power last. Okay. But when you condense, you're gonna take care of the power first. So you're gonna be log 4 3 cube minus log 4 2 cube, and this is mean log 4 3 over 2 3 cube 2 cube like this, or you can also put them inside parentheses, same thing. Okay, or you can also factor out a 3. There's a many way you can do it, but the answer is going to be 27 over 8, right? Make it like this as well. You can also write, I know a lot of you wrote like this. It's also correct, but try to also give the number. Okay. Okay. It's a combination, not really a combination, but it's a lot of term. Using the same tip, whenever you see, whenever you see plus, are they on the top or on the bottom? Top. Whenever you see the minus, is it on the top or the bottom? Yeah, that's it. That's the same tip. But don't change that yet. Just keep it so that you can combine them, because the direction is condensed, right? So log 10 minus log 2 minus log 5 minus log x plus 2 log y plus 3 log 3. So, okay, whenever you see minus, put on the bottom. When you see plus, put on the top. That's it. Is it plus or minus for this one? Where's minus? Is it plus or minus for the first one? Plus, okay, so start with the log. Don't change that into 1. Right? Log 10 is 1, but don't change it yet. Because if you're changing it, they don't have the same base. You need to keep it like this so that you can combine them first. Okay? Now 10 is on the top, right? Bottom is 2. Also 5, bottom or top? Bottom, okay. Bottom on the x, yes. Y to the power 2, very good. So 2 square. You need to take care of the power first, okay? Is it on the bottom or on the top? Top, so y square on the top. And then, what is that? Huh? Cube root. What did you do over here? You do the same thing with this. 3 to the power 3, because you put back the power. 3 to the power 3. Yeah, that's the concept. Whenever you see the negative, put on the bottom. You see the plus, put on the top. All right, let's give Isabel 1 point. 2 times 5. All right, Irene, help me simplify this. So you have log. What do we have inside? Multiply number together or simplify it. 2 times 5 is? And then? You simplify, right? 2 times 5 is 10. 10 and 10, they're gone. So 10 and 10 cancel out. So what do you have left? What is 3 cubed? So y squared over x. Yeah? That's good. Let's give Aaron 1 point. All right, Bernard. ln, is it plus or minus here? Plus. Let's mean it on the top, okay? Is it plus or minus? Plus. It's still on the top. But what you're going to do with the 3? You need to put it back to the power, right? Put it back to the power. So 1/3 to the power 3. Why? On the top, bottom? On the top, right? Yeah. And then you want to just simplify it. So 40, you can write like this. 40, what is 1/2 to the power 3? Don't make it complicated. Just 1/8, yeah. Just 1/8. Yeah. Yeah. Right? You distribute the 3. 1 to the power 3 and 2 to the power 3. 1 to the power 3 is still 1. 2 to the power 3 is 8. Right? So 40 times 1 over 8, y. 40 divided by 8 is 5. So ln 5, y. No, this is the best. Don't write log base e. Okay? If you see log base e, always convert them into ln. If you see the log base 10, just erase the 10. Okay? If you see, whenever you see log base e, always convert them into ln. Always write it ln. And whenever you see the log of base 10, always write them as log. Yeah. No, because 40, you times 1 over 8. That means 40 divided by 8. And 40 divided by 8 is 5. Yeah? Let's give Bernard 1 point. What is this? What is this? What? You just need to. Okay, so you move the 2 back. You have log x plus 6 to the power 2. What else? What else? You distribute it 2. You cannot distribute it when they adding or plus, or adding or subtraction. Huh? Foil? What's the Euler doing here? There's nothing you can do. Only when they adding, but adding outside like this, like log of something, add log of something. Not log, not the plus inside like this. So this is the best you can do. There's nothing else you can do. Okay, this is the final answer. So I put it here for you to realize the difference between when you can condense and when you cannot condense. You can condense them when you have different log. For each of one, they need to have log. This one, you only have the one log. You cannot condense them. Does it make sense? Yeah? Yeah? Okay. Maybe just 2 more. I'm going to cut you just 2 more. So 2 times parenthesis log base 2 of 3 plus log base 2 of 5 minus 0.5 log x minus 1.5 log 2 base 2 of 4. It cut up like O to make 1, okay? But it's not the last one. I'm going to cut you 2, so you only have one more. It looks complicated because it have a lot of things going on, but just take care one by one. Take care one by one. Anyone got the answer? It's a O to make 1, okay? First, what you going to do with a square? How did you put it back? Back where? Back here? Okay, Nico? Okay. Give me here. Log 2. 3 plus 5. You add this one together? 3 plus 5. This one is plus. Okay, so you have 3 times 5 to the power 2. That's correct. But let's break it down so you know why he has that. Okay? You can also distribute them. Okay, you can also distribute them. So you have 2 log base 2 of 3 plus 2 log base 2 of 5. If you want to think like this, right? You distribute the 2 first. And 0.5, you need to convert to the fraction. Okay, 0.5 is 1 over 2 log base 2 of x, and negative 1.5 is, how do you change to the fraction? 3 half log base 2 of 4. I know log base 2 of 4 is, what is the answer of log base 2 of 4? 2, right? But don't changing it because you want them to have the same base. Okay, so far so good for this step. Yeah, all right. Now you can put the power back. So you have 3 square times 5 square, or 3 times 5 square, like Nico said. That's very good. Okay, minus, you also need to move the 1/2 on the front to the power of the x, and you're gonna move the 3/2 on the front to the power of the 4. Yeah, okay. Since this is minus, are they on the top or on the bottom? Bottom. So you have x to the power 1/2, right? Is it minus or is it plus or minus? Minus. Is it on the top or on the bottom? On the bottom. So you have 4 to the power 3 over 2, right? How many of you got to this step? Oh, only 3, 4, 5, 6. Later. You have enough points. Yeah? Do you understand this step? Okay, some faces scare me. I'm gonna explain it again. Where's my ruler? Did you eat it? It's very long. Where is it? Where's my ruler? Okay, anyway. It's just here. Someone ate it? No, I haven't using it. You see my using a ruler? Someone hit it? Yeah. Okay, when? You never seen it? Okay, anyway. Let me say it one by one again. 2 here, I'm gonna put to the power. Okay, let's go to the power. And 2 here, I put it to the power. That's why I have 3 to the power 2. 3 to the power 2. Now this is plus. Plus means it needs to stay on the top. So you have 5 square as well. Now this one also x to the power 1/2. Okay, and then this is also 4 to the power 3 half. I move every. It's right there. I see. Did you have it happen to you too? You're looking for a key, or you're looking for something, or you're looking for the hat, but you're wearing it. Where's my glasses? Where are my glasses? Oh yeah, here. I happen all the time. Anyway, minus on the bottom. Minus on the bottom. So far so good? Yes, you got this step? Any question for this step? Okay, good. Now let's simplify it. This is not simplified yet. Let's simplify it, okay? 3 square is 9. 5 square is 25. This is the square root of x, right? If you don't want to write 1/2, you should write square root of x. I think it look better. Okay, 4 to the power 3 half. What is that? 4 to the power 3 half. What is it? Square root of 4 to the power. Very good. Right now, you can do the power first, or you can do the root first. It's the same answer. Which one better? The root first better. You're dealing with a small number. Do you know what is a 4 cube? You know it, maybe, right? Yeah, but the 4 square root of 4 is 2. That's easier. So square root of 4 is 2, and you have 2 cube. That means 8. Yeah, you can do the root first. So this one become 8. Is there anything we can cancel out? No, huh? What is 25 times 9? 225. So log base 2 of 225 over a square root of x. Let me write over here. All right. Last one. Okay. Do you remember that we cannot combine them when they have a different base, right? Like, do you remember we didn't change this one because we want to keep them at the same base? Remember? Now, can you add them to be 3x? No, they need to have the same base. They need to have the same base, right? They need to have the same base. The question is, how do you change the 3 into something base 2? Does it make sense? So, do you agree that log base 2 of 8 is 3? Yeah, right? So think about it this. You're gonna take the base that you want. You're gonna take the base that you want to that power. Yeah? You're gonna take the base that you want to the base you want it to become base 2. You're gonna take 2 to the power 3. That's your new number. Yeah? Make sense? Okay, and then this is plus. Condense means you go backward from here to here. That's mean you go to log base 2 of ax. That's it. Another way. Okay, let me show you another way. If you understand this way, that's good. I'm gonna show you another way. If you understand this one better, you can also using that. Ready? 3 is 3 times 1, correct? Right? 3 is 3 times 1, right? And then 1 is log base 2 of 2, correct? Yeah, so now I have 3 log base 2 of 2. What can you do with the power? You bring it to the top. So that means it's equal to log base 2 of 2 cubed. And that means log base 2 of 8. That's a long way to do it. The short way is, it's a long way, but I saw that before, that's why. The short way is, you take a look at the base that you want, take that power. That's the new power, that's the new number, right? 2 to the power 3 is 8. Okay? All right?